Hello, everyone. Are you ready to talk about payments? Woo! Yeah, you're going to miss the sunset, but you might learn something about payments. So, actually, give me a quick show of hands. Who here, is tasked with taking payments from their customers or working on payments in general? Okay, a couple people. That's great. And keep your hand up if you feel like you have a good idea, of PSD2 compliance and the upcoming strong customer authentication regulation. Okay. Yeah, that was somewhat of a trick question because that regulation is still, somewhat undefined. But what we do know is that taking payments is going to be become quite a bit more, challenging. And so at Stripe, we're working closely with card networks, EMVCo, and the European regulators to make sure we deeply understand new regulation. So if that's a topic of interest to you and you want to shine at your next dinner party, head over to stripe.com/guides. We publish materials about, kind of regulation, upcoming regulation as information comes available. Okay, enough of the fun talk. Let's jump in. Quickly about myself, my name is Thorsten Schaeff, but everyone just calls me Thor. That's also why my Twitter handle is ThorWebDev. I guess you can imagine the second part, web development. Please do send me a tweet with your feedback or questions. This is very much a learning experience for me as well. Or head into the website later and leave a review. I'm a partner engineer at Stripe, which means I work with many of our largest customers and partners, helping them to build compliant and delightful payment experiences for their customers. Now, if you're unfamiliar with Stripe, we provide APIs and software tools for running internet businesses. At the core of this sits our global payments and treasury network, on top of which we've built an entire suite of products. But today we're going to focus on the core, which is payments processing. There are a lot of complexities when it comes to processing payments. There is, different card networks, different payment methods. There's something like PCI compliance, security, reporting, VAT, all the fun stuff. Fraud. There's a good amount of fraud in payments. And then, there's different currencies going international. So, yeah, a lot of things. And so, apart from producing content like the guides mentioned earlier, we pour our knowledge into APIs and software tools and documentation, of course, that allows you, the developer, to operate in a compliant manner while having a great developer experience, and most importantly, build a delightful experience for your customers. Now, there are a lot of components that play into this. For example, backwards compatible API upgrades. We hold API reviews, every week. It's a diverse group of engineers. If we add a new parameter to the API or completely new functionality, there's a thorough review, and we always make sure that we don't break anyone's existing integration. And then, of course, webhooks, idempotent API requests, especially when you're mobile, connection can be spotty. So, being able to retry a request and being sure, you won't charge a customer twice, that's quite important. But today we want to mainly focus on the following three components. That is payment and authentication methods. So things like 3D secure authentication for card payments, as well as local payment methods across Europe and Asia, for example. Then front-end tools and libraries. We're going to look at how we can use Stripe.js to collect payment details securely and manage authentication, as well as give you access to payment credentials stored in mobile wallets like Apple Pay and Google Pay. And lastly, simple, highly available APIs. We're going to look at how we can use the serverless approach to handle the backend communication with the Stripe API. Now, in its easiest form, taking a card payment with Stripe looks as follows. You create a payment intent. This payment intent is an object that represents your customer's intent to purchase something. So this object holds transaction level information like the amount, the currency, potentially shipping information if you're shipping physical goods, or it can also hold order line items from your basket. This is kind of a basic amount of parameters. There's a lot more to this. For example, if you're taking recurring payments from your customers, or if you're building a marketplace and you need to route funds to different third parties, for example. So this is very much extendable. Now, this payment intent has to be created on the server side. And that's simply because we can't trust the front end, right? That's just the world we live in. And let's be real, we're here in the front end track. The server side can be tough. But nowadays we have tools and services that allow us to quickly build scalable backend components. Now, as you likely know, serverless doesn't mean that there isn't a server. It just means that we are not running our own server, for example, in Node with Express. But we're utilizing the serverless approach where we have a bunch of handler functions that react to certain events. And in our case here, the events are the requests to our backend. Now we can, so for this demo, I'm actually using AWS and Lambda with API Gateway and the serverless CLI to set up configuration and easily deploy to AWS. If you haven't heard of the serverless CLI, do check it out. It's an open source tool, and it basically abstracts away the complexities of all the different cloud providers and kind of make configuration and deployment quite easy. Now we can actually look at what this looks like. So here I have my serverless YAML file. This holds the configuration for my backend component. So here the service is called the Stripe Serverless Payments backend. I'm importing a secrets file because we need to make environment variables available to our application, like the Stripe secret key, as well as the publishable key, which will serve to our front end, which we'll need to tokenize the card details, for example. And then additional things like the webhook secret. Now here I specify my functions. I have a config handler, which is at the config root, which simply serves the configuration variables. Then I have a list product handler that returns products from the backend. And then I have a create order handler, which takes care of creating that payment intent and serves the payment intent object to the client side. Now, if we look in this handler, we're importing the Stripe Node.js library, which we can use to then easily create objects in Stripe as well as retrieve them. Here we have our config handler, that simply serves an object with a bunch of configuration variables. We have our list products handler that returns products from the Stripe backend, from the Stripe API. Then I have a function that actually calculates the total amount. As I said, you can't trust the front end, so we actually have to validate on the back end that the amount that we're going to be charging, is actually what is supposed to be charged. And here I have my create order handler, where I calculate the payment amount, and then I create my payment intent with the amount, the currency. And here I specify allowed source types. Now, allowed source types is a list of payment methods that I can use in order to fulfill this payment intent and actually, get funds from different payment instruments. And I can also hand in a receipt email for Stripe to then send a receipt to my customer. Now, this is pretty much all the code we need on the back end. And now we're going to look at Stripe.js and on the front end and how we can use that to then collect the payment details from the customer and eventually fulfill the payment intent to actually get paid. Now, that was too fast. Okay, so Elements is our UI toolkit for creating delightful, payment flows. Elements lets Stripe optimize your payment flow for security and conversion without you having to give up any control over the user experience and the look and feel. So, for example, this is a bunch of different payment forms that have been built with Elements, and you can see this is highly customizable. So you can apply your corporate design, for example, or for your client if you're building a project. Now, Elements drastically decreases the amount of code you have to write on the front end. It's secure by design, injecting a Stripe-hosted input field via an iframe into your page, meaning your host page isn't exposed to the card details, which is an important piece of fulfilling PCI compliance requirements. But not just that, it provides additional functionality like client-side validation as well as localization. Now, let's have a look. So, in our front-end file, we're initializing the Stripe.js client with our publishable key. We're then loading the Elements sublibrary. This, is the UI toolkit, which gives you access to the UI components, and we only load that when we actually want to render UI components in our front end. Now, because the input field is hosted by Stripe, you can't actually modify it with your own CSS. So that's why you can define custom styling that you can hand to us that we then apply, to that input field. And so the way that works is you create an element. This is a card element here. You pass in your custom styling, and then you mount the card element to a div in your DOM. Now, this card element exposes an on-change handler that you can use to catch, errors. So, for example, if the card number is incomplete, you would get an error object that contains the error message that the card number is incomplete. And this change handler fires every time the user inputs something into that element. And so the nice thing about this is you just get the information. You can actually render that error, for example, anywhere on your page, where it fits you. So we can actually look at that here. So only this input field here, where the card number is typed in, only this is the iframe. You can actually see there's another nice feature, which is autofill functionality. So if you have payment credentials stored on the browser, or for example, in the Google Pay wallet, that will be exposed here as well. And now if we type in, for example, an incomplete card number, we're getting our error message here. Now, I said, the error messages are localized as well. By default, it's the language of the browser, which in my case is German, but no, English. You've seen that. But we're here in Germany, so we actually want to now localize this. So what we can do is we pass in a locale. We set that to German. We save, we quickly reload. And now you can see even the labels here are now localized, as well as the Monat, Jahr, Jahr. So if we now type in an incomplete card number, we get the error message rendered in German. Cool. Now we have a means of collecting card details what we need to do next is attach those card details to our payment intent to actually, complete the payment. So we can look here into our submit handler. 1 second. So here I have a normal submit handler of my payment form submit. I hope you can see that. When that fires, I create the order on the back end. So this create order call calls back to my AWS backend to create the payment intent, which is then entailed here in the order variable. And now if the customer has chosen to pay with card, we can use the Stripe.js handle card payment function to then attach the card element to our, this is the client secret of the payment intent. We can also hand on some additional information like the cardholder name in this example. And then what this handle card payment returns is a promise which will resolve with either an updated payment intent, which then has an updated status, for example, succeeded, or it returns an error if something went wrong. And then once that is resolved, we can jump into our handle payment function. Now this vanilla JavaScript is a bit messy, but bear with me. So we're basically checking here, was there an error? If we got an error object, we simply render that error message on the page. If there wasn't an error, we can check the status of the payment intent. If that was succeeded, we can tell our customer, hey, the payment was successful, your order is on the way. The status could also be processing, and that is, for example, in the case of asynchronous payment methods, like a bank transfer, which can take a while. You would want to tell the customer, hey, we're still waiting on the confirmation of your payment. Cool. Now, let's have a look. We put in a test card number here, so we're operating this in test mode, and for that we provide a bunch of test card numbers. Just going to fill out the payment form. Now in the background, we are attaching the card details to our payment intent, which then automatically creates a charge and tells us, hey, the status is now succeeded. We've taken a successful payment. Cool. Now if we look into the Stripe dashboard, we can now see that's our payment here. Let's zoom out. I guess that's a big enough screen there. So you can see there is a bunch of additional information that was collected, like the IP address, as well as kind of the location of the card, and that information is used by our machine learning-based fraud tooling in order to actually assign a fraud score to the payment. We can see some information about the payment source here. In this case, that was a card. And then we have a charge that fulfilled our payment intent. And we can see here some details. The payment succeeded. There was a pretty low risk score. That's nice. Now, I mentioned strong customer authentication. And strong customer authentication is a regulation that is part of PSD2, which is going to come into effect next year, September 2019. That means by next year, September, all card payments within Europe will have to be strongly authenticated. One means of authenticating a card payment is, for example, using 3D Secure, or you might know it as Verified by Visa or MasterCard Secure. And the regulation demands that any payment that is above 30 euros has to be strongly authenticated. Now, if we want to prepare for this regulation, we can now actually specify a rule in our Stripe dashboard. And Radar is part of our machine learning-based fraud tooling, and you can actually see that there is already some default rules here. So, for example, if our fraud tooling thinks, the risk level here is very high, it's the highest category, we then want to perform 3D secure authentication in order to shift the liability for fraudulent chargebacks to the card issuer, which is nice, so we won't have to pay for that. Additionally, there's a rule where we want to use 3D secure if the card, for example, requires that. All cards in India, for example, already require 3D secure authentication. If you don't perform that, all payments will fail, will get declined. As well as a good amount of cards in the Nordics do require 3D secure authentication. And now, in preparation for the SCA regulation, we can actually specify a rule here that says, if the amount in euro is above 30, then we want to perform authentication. Now, I enable this rule, and the nice thing about this integration path is, without changing anything, in my code, I can now go back to my payment page, to my checkout page, and now you can see the amount in my basket is above 30 euros. And if I now go through the checkout, I use the same test card number here that I used previously. And what happens now is, when we create the payment intent and we attach the card details, we realize that, hey, the amount of the payment is above 30 euros, so we have to perform authentication. Now, in test mode, there is, this lovely Stripe test page. In real life, there's going to be a somewhat ugly-looking verified by Visa page. But, the idea is that we put in our password. We might get a one-time password, via SMS. And then, once that authentication is completed, our promise will resolve again, and we will get the succeeded status. Now, the nice thing is there is 3D Secure version 2 in development, which will ideally make the authentication experience a lot smoother. So by exchanging more information with the card issuer in the background, we might actually not need to show a challenge, but that specification is still in development. Cool. Now we've been able to accept card payments and perform authentication. But if we look on a global scale, 55% of online checkouts are not completed with a card. And for example, if we look into our neighboring country, the Netherlands, more than half of customers prefer to pay with a bank payment method called Ideal. Now, Ideal demands a full page redirect to the banking page or the banking app on mobile. So that means we can't actually put that into the iframe, but we have to perform a full page redirect. And so in order for our application to handle that, we will need to make some changes. Now let's have a look. So in our backend, we now need to say we want to allow Ideal as a payment method. And because it's a full page redirect, we need to also specify a return URL. And I'm just going to simply take the origin out of the headers here. It's not very secure, but for the purpose of this demo, that will do. And now we can quickly deploy this to AWS. Cool. And while that is deploying, we're going to look at the changes we need to do on the front end. Now, Ideal is actually a payment method that works with a lot of different banks in the Netherlands. And so in order to create a good experience for our Dutch friends, we want to show them a list of the bank options so they can easily pick the bank that is theirs and then go straight to their bank authentication page. So for this we have a UI element that is called Ideal Bank. Also here we can pass in our custom styling and then we mount that into our DOM with this ID. And so let's quickly see if, yep, our function has deployed. So now we can go back to our checkout. We put in our Dutch address and now we say ideal. And this here is now the ideal bank element. I have a bank account with Bank. It's a new challenger bank in the Netherlands. It's mobile only, it's very delightful. And now we're creating the payment intent. We now have a handle ideal handler, which will then actually perform the redirect. Again, in test mode, we provide a test redirect page because you, for example, you might not have a Dutch bank account, but you still want to test the end-to-end flow of this. There is some information about the payment source here, for you as the developer. And there's also a link to a payments guide where you can get some more information and details about this payment method. But in the end, we authenticate this method. Once that authentication was successful, we are returned back to our page. And we will append kind of the ID as well as the client secret of the payment intent to the URL, which you can then use directly on the front end to again retrieve the status of the payment intent and verify that it was successful. Cool. So now we got card payments, we got bank payments, but you might say, hey, we already had that in the 90s, so show me something new. Glad you asked. So the presentation is alone. 1 second. Come on. All right, there we are. Now we've learned about ideal. Oh yeah, what I forgot. There's a lot more of these redirect-based payment methods. And the nice thing is that once you're able to handle this redirect flow once, you can pretty much handle all of those redirect-based payment methods. And so within the Stripe dashboard, you can simply activate the methods you want. For example, Alipay is one of those as well. And then you can reach millions of customers in China, for example. Now, the great thing with mobile wallet payment methods like Apple Pay and Google Pay is that we can read the payment credentials out of the wallet, but not just that, we can also read additional details like the shipping address, the billing address, as well as contact information like the email address and the phone number. So by using kind of these mobile wallets, we can actually fast track the checkout experience. And so offering this kind of fast track payment journey to decrease the amount of steps needed to check out can significantly lift your conversion, especially on mobile. But where do we start? How do we get Apple Pay or Google Pay into our web application? And the nice thing is there is an element for that. So actually, if you have, does anyone have Apple Pay on their phone? Okay, yeah, I forgot this is Germany. But number 26 actually has Apple Pay support already, I think. So, if you get one of those accounts, you can actually go to the documentation and you can test it out yourself. But of course, we're also going to look at, how we can do this. So we have an element within our UI toolkit that is called the payment request button. Now you might have heard of the payment request API, which is a web API that gives you access to payment credentials that are, for example, stored in the browser, so on Chrome. And the nice thing is that this will give you a natively rendered payment sheet, instead of you having to build that checkout page yourself. This payment request API, is still experimental in development. So Apple Pay is kind of its own implementation, as well as Google Pay's Pay.js as well. And so the idea is that we kind of wrapped all those different payment methods into one payment request button. And depending on which end device is being used, the right button is then rendered, if one of those methods is available. So what we need to do is we need to create a payment request object. This payment request object is used to then, show the payment sheet natively on the end device. And then we have a callback listener here for a payment source that is become available. So once our customer selects to pay with Apple Pay, the payment sheet pops up. They say, hey, they want to pay with their card stored in the wallet. And when all of that was successful, this callback will fire. And we now have a payment source that we can charge. And the way we do that here is we basically just confirm our payment intent with the ID of that source that is contained within the event. There are some additional callback handlers as well. For example, the shipping address change. Because the shipping address is selected within the native payment sheet, we give you callback events where you can, for example, recalculate if the shipping address changes, for example, the country changes, you might want to charge them more because shipping is more expensive. And then, lastly, we create a payment request button with our payment request. And we actually have a function to check if we can make a payment, which basically means is any of those, are any of those mobile wallets available on this end device? And if that is the case, we then mount the payment request button into our checkout form. Okay, let's save this and go back to our page. Now, on Chrome here, we now have access to the payment request API. So this is actually a native Chrome window. But for example, if we now open Safari, we go to our demo page, we now get an Apple Pay button because Apple Pay is available in Safari. And now if I click here on the button, the Apple Pay sheet will come up. I don't have the new MacBook with the fingerprint, so I actually get a little message on my phone there. I just scan my fingerprint. Sorry, I closed it instead of scanning my fingerprint. 1 second. Okay, scan the fingerprint. Right, and there we are. And now we confirm the payment intent with the payment details stored in that wallet. Cool. And then, for example, if that is opened on a mobile Android device, you would have access to Google Pay, for example, on the Android phone. Yeah, that was the Apple Pay demo. Cool. Let's quickly recap. We've been able to accept payments with minimal server-side code. We've used Stripe elements to build a delightful checkout experience tailored to our customer's location and device. And we've learned about upcoming regulation and feel well equipped to tackle it next year. Cool. I hope this gave you a good overview of how you can use the Stripe tools and APIs to build delightful and locally relevant payment experiences for your customers. Some of this functionality is still in private beta, so if you want to get early access to this, do shoot me an email to thor@stripe.com. Alrighty, that's all from me. Thank you very much for sticking around so late on a Friday evening. And do shoot me a tweet or put the feedback, into the website. And if you have any questions, also tweet at me or send me an email, or shout them out now if you want to stick around. Thank you.
Really secure payments.
Mm-hmm.
Where the user intent is required to complete the flow. How do you deal with recurring payments in that case?
Yeah, so there is, excuse me, there is use cases where only the initial payment of a subscription will require authentication. So for example, in the Nordics, you will only have to authenticate the first payment, and then the issuing bank will basically remember that that payment was authenticated, and any future recurring payment that then is sent with a recurrent flag, for example, will be accepted. That doesn't work in India as far as I know, so yeah, there is pretty much you have to perform authentication every time, which is quite annoying. Yeah, so the question was, is PayPal offered on the Stripe platform? Not as it stands today, unfortunately. So you would have to implement that separately. Yeah.
You were talking a bit about customization, and that you can provide your own styles. Can you also customize messages? So it was like super formal speaking, like in the error message. Can you go like more informal or whatever fits your corporate identity or whatever it is?
Yeah, so the message itself, from our end, you won't be able to change that, but the error object also includes an error code that you could then, for example, use to create your own mapping if you wanted to, yeah. Cool. If there aren't any more questions, thanks so much for coming, and enjoy your Friday night and your weekend. Cheers.